right, so we are going to be factoring to solve quadratic equations today. So just a quick warm up on solving these. Remember that when we are solving using square roots, we want to get that x squared by itself. So we are going to add 13 to both sides. And so that gives us 4x squared equals 51 plus 13 would be 64. And then when we would divide by 4, 64 divided by 4 would give you 16. And so when you take the square root, that would give you x is positive or negative 4. So then with number 2, we're going to subtract the 63 so that we can get the x squared by itself again. So we would have 7p squared equals negative 63. When we divide by 7, we get p squared equals negative 9. But remember, when we take square roots, we can't take a square root of a negative number yet, and so then this would be no solution, at least for now. You guys will deal with that when you get into Algebra 2. For number 3, we are going to factor, and so remember when we factor, we draw our box, and we draw an x. We put the 2c squared in the top left, 2c squared, and negative 11 in the bottom right. And so when we multiply those, that would give us negative 22c squared, and they have to add to get a positive 21c, because remember, it's your middle term. And so with negative 22, I know one of them has to be positive and one of them has to be negative, and it would just be 22 and 1. And since this is a positive 21, we're going to be doing 22 minus 1. So then we fill in the rest of our box. And then we go ahead and factor each row. So in the top row, we can take out a 2c. And when we do that, 2c times c gives me 2c squared, and 2c times 11 gives me 22c. And so then on the first column, if we were to take out a c, that would leave negative 1. And then negative 1 times 11 gives us negative 11. And so the factored form would be c plus 11 times 2c minus 1. Okay. For number 4, we're going to do a box and an x again. So we'll draw our box, and we'll draw our x. We put the first term in the first box, last term in the bottom right box, and we multiply them together. 4 times 15 is 60, so that would be negative 60 m squared, and they are going to add to be negative 4. So thinking about what multiplies to get 60, we'd have 1 and 60, 2 and 30, 3 and 20, 4 and 15. Let's see what else we have. We can do 5 and 12, 6 and 10, and I think that might be about it. Yep. So if you notice, if we're looking for a difference of 4, that's really going to be this 6 and 10, because if I do negative 10 plus 6, that would give me a negative 4. And so we'd put in negative 10m and positive 6m. And then we take out our greatest common factor for every row and column. And so we can take out a 2m in the top. And if we take out a 2m, that would take 2m, because 2m times 2m gives us 4m squared. And then 2m times negative 5 gives us the negative 10m. And so then if I factored out the 2m earlier, then 2m times 3 gives me 6m, and positive 3 times negative 5 gives me negative 15. And so then our factors would be 2m minus 5 and 2m plus 3. Okay. So for what we're doing today, you have to know how to factor. And so in the previous stuff, we've solved quadratics by graphing and by using square roots. And remember when we were graphing, we had to find where it touched the x-axis, right? And it would either touch once, like the middle graph, twice like the graph on the left, or it just wouldn't touch the x-axis at all, and that would be a no solution one. And so remember, that's when, if you're solving by equations, it'd be like number 2, where you solve and you get no solution. Now, the square root method only works if b equals 0, and so you would have to have a binomial. But you can solve some quadratic equations by using the zero product property when b is not equal to 0. So the zero product property basically just says that if two things multiply together, a and b equals 0, then we know that a has either A equals 0 or B equals 0, and we don't know which case it is, and so you have to do both. So when you factor a quadratic, then both of your factors must be equal to 0. Okay, so to see this in action, if you look at example 1, I have two things getting multiplied together, 2x plus 3 and x minus 4. And so I don't know when it's going to be 0, but I know that if 2x plus 3 equals 0, then this would be 0. And I know that if x equals minus 4 equals 0, then it is also going to be 0. So we solve for both. So we would subtract 3 with this one. 2x equals negative 3, and then we would divide by 2. So x equals negative 3 over 2. Then, when you come over here and solve this one, solve them separately. Make sure you're not trying to do the same steps, but we would get x equals 4. And so then our two solutions for this quadratic is x equals negative 3 over 2 and x equals 4. And think about it, on a graph, that is where it would be touching the x-axis. Okay? So for B, we have two things getting multiplied together. And again, I just need one of them to equal 0 to make this true. So in order to figure out when that happens, I have to set them both equal to 0. Okay, and so with negative 5n equals 0, we would divide by negative 5. But of course, that doesn't really do anything for us because n just equals 0. And then when we solve 6n plus 7, we're going to subtract that 7. And that gives us 6n equals negative 7. And then we divide by 6 to get n equals negative 7 over 6. And keep in mind that when you're doing this, you are probably going to get fractions sometimes. Just leave it as a fraction. It's totally fine. So to solve quadratic equations by factoring, you first want to write it in standard form. And with standard form, the main thing that you just haven't seen yet is that x has to be equal to 0. And that's a really big thing because if it's not equal to 0, you can't use the zero product property. So once you have that in factored form, you're going to factor it completely. Then you're going to set each factor equal to 0. And that's just like example 1. And then you're going to solve for x. Okay? So if I have x squared plus x minus 42 equals 0 by factoring, first I need to factor this part only. Okay, so if I look at this, we're going to draw our box and we're going to draw our x. And so we would write x squared minus 42 in the bottom right. When we multiply those together, it is negative 42x squared. And then in the bottom, we would have just 1x. And so factors of 42 would be 6 and 7 in this case. And again, if you have to list the factors out, that's totally fine because you could have 1 and 42, 2 and 24, 3 and, let's see, 42 divided by 3 is 14. Okay, you can still make that list if you need to, but ultimately you do end up with 7x and 6x. And because it's a 1, I know that I'm going to have 7x minus 6x. Okay, and so then when we're taking out our GCF for this row, we can take out an x, which would leave me x minus 6 on the top. And then if I take out an x, I'd be multiplying by 7. And so 7 times negative 6 gives me that negative 42. And so then I take this, and now that I have it factored, I'm going to write it as x minus 6, x plus 7, because that is our factored form. And we're just going to set it equal to 0 again. And so then this is where you break apart and you solve them separately. So x minus 6 equals 0 and x plus 7 equals 0. Again, both of these are true. They just happen at different times and you have to figure out when they happen. And so we are going to add 6 to this equation on the left to get x equals 6. And then we're going to subtract 7 to x plus 7 so that we get x equals negative 7. And so our solution or our factors of this are going to be 6 and negative 7. Okay? So again, think about it on a graph. That would be crossing at positive 6 and negative 7. So it's going to be a big parabola. Okay? All right, so with 3, we're going to still solve by factoring, but you notice that this right here is my problem because it has to be equal to 0. And so first we have to make that happen. Since this is a positive 9, I can just subtract the 9. And that would leave me with 2z squared minus 17z minus 9 equals 0. And remember, that's really what we want, because now we're going to factor this left side. So I'm going to go ahead, draw my box and my x. With this 2z squared, we're going to put the 2z squared in the top left and the negative 9 in the bottom right. When we multiply those two together, we get negative 18z squared, and then in the bottom we're going to have negative 17z. And so then factors that multiply to negative 18 but add to negative 17, you'd have 1 and 18. That's probably our winner. 2 and 9, 3 and 6, and that's it. So if you think about 1 and 18, we know that one of these has to be negative because this 18 is negative. And because the 17 is negative, I know my bigger number needs to be negative. So we'd have negative 18z. Okay, so we put that in our box and then we factor. So looking at the top row, I can factor out a 2z. When I do that, 2z times z gives me 2z squared. And 2z times negative 9 gives me negative 18z. And so then if I took out a z, z times 1 gives me 1z, so I'm going to have a plus 1, and 1 times negative 9, our checker, is negative 9. And so factored form of this would become z minus 9 times 2z plus 1 equals 0. And again, these two things multiplied together make this thing in the pink. And so that's why we want to have it in factored form and equal to 0. So now, because we have it equal to 0, we can take each of these factors and set them equal to 0. Remember, when you're solving for these solutions by factoring, you are factoring and then solving the equation. So for z minus 9, we will have to add the 9 so that it can cancel out with the negative. So we would have z is positive 9. And then with 2z plus 1, we're going to be subtracting 1. 2z equals negative 1, so then we will divide by 2 to undo the multiplication. And z equals negative 1/2. And so our solutions to this quadratic, where it would touch the x-axis, would be at 9 and negative 1/2. Okay? So for 4, we are still factoring, but notice there's a lot of extra stuff on that right side, and I need it to be equal to 0. So I need to move all of it. So we're going to subtract this 3k squared first, just so we can combine it with the 8k squared. And so when we do that, that gives us 5k squared plus 13k minus 2 equals negative 10. And then we're going to add the 10, and 10 is a common term with negative 2, and so everything gets to stay exactly the same, except negative 2 plus 10 gives us positive 8. And now we have equal to 0, and that's what I need. So now we're going to factor this thing, 5k squared, plus 13k plus 8. Okay, so I'm going to come over here just so I have space. Oh, and I wrote it opposite than usual, but it's okay. So we have 5k squared and 8 in the bottoms. 5k times 8 gives me 40k squared. And then in the bottom, we would have 13k. So then figuring out what multiplies to 40 and adds to 13, you'd have 1 and 40, 2 and 20. Again, if you don't have to list these, then don't. But 4 and 10, and 5 and 8, and looks like 5 and 8 is probably our winner. And because if you think about this is positive, so we know they both have to be positive or negative. And since this is positive, we know they are both positive. And 5k plus 8k would give us 13. So then we put that into the box, and then we factor. The top row, we can factor out a 5k, which would leave me k plus 1 on the top. And then if I take a k out, that would leave me with plus 8. And 8 times 1 gives me 8. So then that leaves me with k plus 1 times 5k plus 8 equals 0. So again, once you get to this point, once they're in factored form, you're going to break them apart and set them both equal to 0. So k plus 1 equals 0, and 5k plus 8 equals 0. Okay, so then we are going to subtract the 1 on the equation on the left, and k equals negative 1. And then we are going to subtract 8, and we get 5k equals negative 8. And then we will divide by 5 to solve, which gives me k is negative 8/5. Okay, And that is it for that one. Again, all of these are where the parabola would touch the x-axis. Okay? So, example 5. With this one, we're still going to have to rearrange. And honestly, you can move stuff to either side. Since there's less stuff on the left side, I would probably move that. But you could move the w squared as well if you wanted to keep your w positive. And actually, we're going to do that because it'll make factoring easier. So, with that, we're going to subtract the w squared, and that would give us 3w squared minus 10w equals 6w minus 21. And so then we're still combining, so we'll subtract the 6w, one thing at a time. Some of you I know can handle more than one thing, and if that's you, that's totally fine. But that leaves us with 3w squared minus 16w equals negative 21, and then we add the 21, which gives us 3w squared minus 16w plus 21. Okay, so now we are going to factor this little bit, because remember, we factor it and then we come back to it. So when I draw my box in x, actually I'm just going to draw x underneath for now. We would have 3w squared in the top left, 21 in the bottom right. Multiply those together to get 63w squared, and it needs to add to get 16w. So with 63, that would be, let's see, 1 and 63. 2 doesn't work. 3 would be, let's see, 63 divided by 3 is 21. I don't think it can be divided by 4 or 5 or 6. We can divide by 9, that'd be 7. And it looks like if we're getting to 16, that's going to be my winner. And the reason why I know is because this is positive and this is negative. So I know they both have to be negative and they just have to add to get it. So negative 9w and negative 7w. Okay, so then when I factor, looking at the top row, I can take out a 3w. And when I do that, that leaves me with just w on the top. And so then that would leave me with minus 9. And then in the bottom, if I took out a w, that would leave minus 7. And so in factored form, that would be w minus 9 times 3w minus 7. And it is still going to be equal to 0, because remember over here in the blue, this factored is this, these two things, and then equal to 0 still. And so then we take the two factors, and we set them equal to 0. And then we solve them. So with w minus 9, we just have to add the 9, and that gives you w equals 9. And with the other one, we're going to have to add 7, which gives me 3w equals 7, and then divide by 3. So then w is just positive 7/3. Okay. So then, last example, we have the area of the rubber coating for a flat roof is 44 feet squared. The rectangular frame the carpenter built for the flat roof has dimensions such that the length is 3 feet longer than twice the width. What are the dimensions of the frame? So if we draw a little picture, we know that the area is 44 feet squared. Okay, and we also know that the length has a relationship with the width. So I'm going to go ahead and just label the width. It's going to be w. Now length is 3 feet longer than twice the width. Twice the width tells you that it's 2 times w, right? And then since it's 3 feet longer, we're going to be adding 3. And so for this area, this is where you have to apply what you know. Area is multiplying your length and your width. And so in this case, we would have w times 2w plus 3. And when you distribute, that would be 2w squared plus 3w. Now we know what that value is because this would be area, and our area is 44. And so now we're just solving stuff that we've already been doing in a different way. So we're going to be subtracting 44. That gives us 2w squared plus 3w minus 44 equals 0. Again, 0 is our magical thing that we're trying to get to. So now we have to factor this side of it. So you draw your box and your x, and that would give us 2w squared and negative 44. And when you multiply that, that would be negative 88. And we're going to have 3w in the bottom. And so thinking negative 88, that'd be 1, 88, 2, and 44. 3 does not work. 4 is 22. 5 doesn't work. 6 doesn't work. 7 won't work, but 8 will work with 11. And notice 8 and 11 have a difference of 3. And since this is negative, I know 1 is positive and 1 is negative. So these are going to be my winner. And so since it adds to be a positive 3, I know it has to be a positive 11 minus 8. So then you fill in the rest of your box and you factor. Top row, we can take out a w, which would leave me 2w, oops, and I did not give myself much space, plus 11, because again, w times 11 gives me 11w. And then if I took out 2w, 2w times negative 4 is what gives me negative 8w, and negative 4 times 11 gives me negative 44. So then factored form is going to be 2w plus 11 times w minus 4 equals 0. Again, this is our factored form when we multiply these. So then we set each of these equal to 0. 2 plus 11 equals 0, and w minus 4 equals 0. And so we would subtract 11, and that gives you 2w equals negative 11, and then we divide by 2 to get w equals negative 11 over 2. And with the other one, we would just add 4. That one's the nice one. And so that would just give us w equals 4. Okay, and so keep in mind when you are solving by factoring, after you factor, it's okay if your answer is negative. That does not indicate no solutions. Okay, that is only when you're solving by square roots and you have x squared equals some negative number. Okay, so your closure is to explain the process of solving a quadratic equation by factoring. So if you think about it, it has to be standard form equal to 0. Okay, and then you are going to factor your standard form. Oopsie. And once you factor standard form, you're going to set each factor equal to 0. And solve. Okay, so that is solving quadratics by factoring. Let me know if you have any questions. If you do, you can just comment below. And if not, then I will see you in class. Have a lovely day.